Hi guys, very good morning. Welcome to the session. Myself Dinesh. So today's session is based on uniform and exponential random variables. Okay. So we're going to talk about uniform and exponential random variables. So in this week, I've been covering a lot of concepts based on random variables. So in the last 4 sessions, I've covered probability density function, cumulative distribution function, moments of random variable, and in yesterday's session, I've covered Gaussian random variable or Gaussian distribution. So in today's session, I'm going to cover uniform and exponential random variables. And in tomorrow's session, whatever concepts I've discussed in this week, in the 5 classes. So I'll be solving questions based on all those concepts in tomorrow's session at the same time. So if you wish to learn random variables very well, you can attend the classes. You can attend the previous classes as well if you wish to learn those concepts. Fine, so let's continue with the session. Right. So these are my subjects of expertise: communication systems and signals and systems. So if you wish to ask me any doubts, you can contact me in this Telegram group. Okay. So what is the agenda of today's session? So first I'll quickly solve yesterday's homework questions. I've given you some homework questions in yesterday's session based on Gaussian random variable. First I'll solve those 2 questions quickly. And after that we will move on to uniform random variable. We'll talk about what is this uniform random variable and what is the mean value of it, the mean square value of it, what is the variance of it. Okay. So we'll derive those moments of uniform random variable so that next time onwards, whenever you look at uniform random variable, you can quickly get the answers for moments. Okay. If you forget the formulas also, no problem. You can go from the basics and derive them in the exam also. Similarly, exponential random variable also we'll discuss in very detail. So we'll talk about moments of exponential random variable also. Right. I'll talk about the little small variations of exponential random variable as well. Hi Gokulan, good morning. You too have a great day. So problems based on, we'll talk about some problems based on exponential random variable and uniform random variable. Okay. And then I'll give you some homework questions as well in today's topic as well. Right. So these are the 2 questions I've given you as homework in yesterday's session. So let me quickly solve them. Yeah. A Gaussian random variable x has mean 4, which means x bar is given as 4. X bar is given as 4 and variance sigma x square is 16. Okay. Now they're asking us to find the mean square value. Variance we know, mean value we know. How about variance? Variance is mean of squared value. It is the average of squared value, or we can also represent it as expectation of x square. There are 2 ways of representation of mean square value, this way or this way, both are fine. And we know the relation between mean square value with variance and mean value. So mean square value is equal to variance plus mean whole square. Mean whole square is different from mean square value. This is mean value squared. This is squared value. Found the average of, this is the average value of the squared value. This is first find the average value of x and then square it. So this also represents DC power. This represents AC power. This represents the total average power. Okay. Hi Rahul, good morning. So sigma x square is given as 16 and mean value is given as 4. You can substitute it here, 4 square. So 16 plus 16 is 32. So 32 is the mean square value. So we found the mean square value of the random variable. Next, how about p of x less than 0? P of x less than 0 means the probability that the random variable takes values less than 0. So is it not same as, will it be different if I write it like this? X less than or equal to 0 or x less than 0, it will be same for continuous PDF. For continuous PDF, there is an equal to or not, it will not matter as long as there is no impulse at that point. At 0, if there is no impulse, this equal to is there or not, it will not change the answer. Okay. So in Gaussian random variable, we know that there are no impulses. So hence, if there is equal to or not, the answer will not change. So how is this looking like? Is it not looking like the CDF function value at 0? The CDF function value at 0, and this is CDF of this random variable. Let us convert this into CDF of normalized Gaussian distribution. How we write it? F of 0 minus x bar divided by sigma x. See this one? I have derived a relation, beautiful relation between any Gaussian random variable with the normalized Gaussian random variable. We have derived it in yesterday's session. You can go through that if you have missed that session. Now, f of 0 minus, what is x bar? X bar is 4 divided by sigma x is also 4, which is equal to f of minus 1. We can leave it at this place. F of minus 1 is also same as q of 1. It is also same as 1 minus f of 1. It is also same as 1 minus q of minus 1. So all these four answers are correct. All of them mean the same thing. They all give the same value as answer. So in the options, you may not find this. You might find any of them. Any four of them you might find in the answers. Okay. I hope this part is clear. This is an easy question. So if you are attending this class for the first time, if you are not understanding this, kindly go through the previous session, yesterday's session. Right. So if you have not subscribed to the channel, kindly subscribe, and if you like the content that I'm presenting, don't forget to press the like button. Right, next one. A Gaussian random variable x has a mean 2 and variance 1. Find the mean square value of the random variable. Talking about again Gaussian random variable. Here mean is 2, variance is given as 1, right? Mean square value. Simple concept, same thing. Mean square value is equal to variance, which is AC power plus DC power. So variance is given as 1 here, and mean is given as 2. So mean whole square is 2 square, which is equal to 5 units. So mean square value is 5 units from the second question. And what they're asking next is P of x greater than 3. So P of x greater than 3. Always try to express this probabilities in terms of CDF function. So CDF function does not deal with x greater than values. It deals with only less than values. It is, let's write it as, we are not changing, without changing the value. Here we are interested in the random variables values from 3 to infinity. Probability of the random variable taking values 3 to infinity. Instead of that, what we can write is 1 minus probability of x less than or equal to 2. So this one, then this one, they are representing the same answer, right? Here they're asking us to find the probability of x taking values greater than. Since total probability is 1, from that we are removing the probability of the random variable values that we are not interested here. Whatever values we are not interested here, we are taking the probability of those values and we are removing it from the total probability 1. So that we will effectively get the probability of random variable taking values greater than 3. Next, how about this one? Is it not looking like CDF function value at 3? Yes. So we can write it as, let us convert this into normalized Gaussian distribution function. So f of 3 minus x bar divided by sigma x, which is equal to 1 minus f of 3 minus, subtract the mean. How much is the mean in this case? Mean is 2 divided by variance is 1. So this is 1 minus f of 1, which also can be written as q of 1, which also can be written as f of minus 1, which also can be written as 1 minus q of minus 1. See this? Is that okay? Yes. 4 answers are possible. So any one of these 4 can be there in the options. So I hope it is clear till this point. So with this, we are done with the homework questions. So let's continue with the actual discussion of today's topic, which is uniform distribution and exponential distribution functions. Can I go ahead? Right. Uniform and exponential random variables. First, let us talk about uniform random variable. So this is the easiest distribution to deal with. Uniform random variable or uniform distribution you can call. Right. If x is a uniform random variable, if x is a uniform random variable, then Let's plot the PDF. I'm not drawing y-axis because y-axis can be anywhere. I'm talking about general uniform distribution. Uniform means equal probability for whatever values it is taking. The random variable, it might be taking some range of values. Let me say the starting point of that range is A and ending point of that range is B. Let me say that. I'm talking about general case. So A can be some negative positive value, B can be positive negative, B can be some positive value or negative value also. So irrespective of A and B being positive or negative, so whatever discussion we are going to do here will be valid. We are talking about general case. Random variable X, and we are plotting the PDF here, fx of x. Anybody says uniform distribution function, if you plot its PDF, if you plot the PDF of uniform random variable, it is going to look like a rectangular shape. It is going to have a rectangular shape. But if it is, since it is PDF, its area should be 1. Since it is PDF, its area should be 1. Can anybody tell me what is the height of this uniform PDF? What is the height of this function? The height is, what is the height? It is 1 divided by b minus c. Y-axis can be here, y-axis can be here, y-axis can be here based on a and b values, right? So that's why I'm not drawing y-axis, because based on a, if a and b, if a is negative, b is positive, y-axis is somewhere here. If a and b both are negative, y-axis is somewhere here. If a and b both are positive, y-axis is somewhere here. Okay, since we are talking about general case, I'm not drawing the y-axis because we are not means we are talking about general a and b values. We are not assuming they are positive or negative. We are not assuming anything, right? So b minus a, highest point minus lowest point will give you the width. This width is b minus a, right? So if the height is 1 by b minus a, then only the area of the rectangle will turn out to be 1. Only if the area of this rectangle is turning out to be 1, only then we can call it as probability density function, because the basic property of probability density function is, there are two properties. It should always take positive values and its area should be 1. These are the two properties of probability density function. If a graph satisfies those two properties, yes, we can call it as probability density function graph. So this is uniform PDF, its area is 1. So what is the equation of it? If you want to write it mathematically, how do you write it? We can write it as, it is 1 by b minus a is the equation for a less than x less than b, and it is also equal to 0 elsewhere. For the remaining values of x, its equation is 0. Or we can also write it as 1 by b minus a into, instead of these two lines, you can use some signals concepts, and you can also write it as u of x minus a minus u of x minus b. Can be flexible. So in sometimes they might give you in this format, sometimes they might give you in this format. The answers, if your answer is a uniform PDF, you don't expect it to be in the format that you have learned. It can be in a different format. We should be able to recognize it. Okay, see this one? Subtraction of two-step functions always produces a rectangular function. Right, this is how we can write it. So a simple PDF, uniform PDF is very, very simple. Now let us find the important stuff in this one. Important stuff here. So what is the expectation of x, the mean value of this uniform random variable? What is the mean value of this uniform random variable? Let's find it. Okay, let's go with the basics. If you want to find the average value of x, take that x value, the possible values for the random variable, multiply with its probabilities, and then just add it up. Since it is continuous random variable, we are doing integration from minus infinity to plus infinity. This is the basic formula for mean value, which is equal to, do we know fx of x? Yes, we know fx of x. We can substitute it here. So this is the formula for any PDF, not only for uniform, for any random variable. We have done this stuff. We have used this in the last 2-3 classes also. So for this particular PDF, we can substitute this equation here and we can resolve it. So it is x into, what is the equation for fx of x? It is 1 by b minus a is the equation, but 1 by b minus a is not the equation for all values of x. It is the equation only from a to b values. For x values from a to b only, this equation is valid. For the remaining values, it will be 0. The equation of PDF is 0. Equation of PDF for this PDF, the equation is 0 for remaining values of x, like b to infinity or minus infinity to a. This equation is 0. Right. Next, so let us calculate it further. So 1 by b minus a aside, 1 by b minus a is a constant. Put it outside the integration. What is left? Integration of x. Integration of x is x square divided by 2. Limits from a to b. The next part becomes 0. So this is 1 by b minus a, and this is b square minus a square divided by 2. B square minus a square, we can write it as b minus a into b plus a. So b minus a gets cancelled. It will look like b plus a divided by 2 or a plus b divided by 2. What is b plus a divided by 2? Whenever you do average of a and b values, what you get is the midpoint. What you get is the midpoint. Correct? So this is the midpoint. The midpoint, and can you observe that this PDF is symmetric with respect to the midpoint? This PDF is symmetric with respect to x bar. Mean value is x bar, which is equal to a plus b by 2. Not only this PDF, any PDF, if it is having symmetry with respect to a particular line or a particular point, then that point will be the mean value. See, for Gaussian random variable, what is happening? It is symmetric with respect to its midpoint or the mean value. Any PDF which has symmetry, it will be symmetric with respect to the mean value. So next time onwards, whenever you see some kind of PDF with some kind of symmetry, symmetry means it need not be having even symmetry. It will definitely not have odd symmetry, because PDF will never take negative values. So PDFs will never have odd symmetry. PDFs can have even symmetry. Sometimes even symmetry means it is symmetry with respect to y-axis. See this one? But this is not a symmetry with respect to y-axis. There is a symmetry with respect to some point. With respect to whatever point the PDF is symmetric, that point is nothing but the mean value. Okay, you can take any other shape also. So for example, I'll take some examples. Okay. For example, I am saying this represents a PDF. This represents a PDF. And let's say this point, the point with respect to which it is symmetric is 5. Then you can say that mean value is 5. If any PDF is having symmetry with respect to any point, some point, that point definitely represents mean value. So if you want, you can write the equation for it and use the formula for mean value, integration of x into fx of x dx. You will finally end up in 5 only. See, this you cannot apply these basics for PDFs which are not having symmetry. For example, let's say this is 3 and 7. For example, let's say, so this is 3, 5, 6 point. See this one? Is this having symmetry? With respect to any point, is it having symmetry? This is having symmetry, I agree. Symmetry with respect to 5. Hence, 5 is the mean. Here, no symmetry. It looks like it is having symmetry, but if you carefully observe, it is not having symmetry, because this width is 2 units and this width is only 1.5. So if you draw a line here or anywhere, with respect to any line, with respect to no line, this is having symmetry. Correct? So here, will it not have any mean? It will have mean. Any random variable will have some mean value, but we can't figure out just by looking at it. So you have to go with the formulas. So write the equation for fx of x, write the equation for this line, write the equation for this line, and then apply the formula, integration of x into fx of x dx. Apply the formula for mean value. Then you can get the mean value. But you can't see it and recognize the mean value directly here, because there is no symmetry here. Only when there is symmetry, yes, you can recognize. The shape need not be only Gaussian or triangular shape or uniform, but some other shape also. Any shape which has symmetry, we can recognize the mean value directly. Only mean value we can recognize. Okay, mean square value and all those things we can't recognize. Okay, is it okay? I'll take one more example. Okay? Is this having symmetry? See, here width is 2, here width is 2. With respect to this midpoint, is it having symmetry? Yes, right? With respect to 6, it is having symmetry. So if x is a random variable here, so this is having symmetry with respect to a point 6. Hence, the mean value here we can recognize directly. Here we can find mean value, but we can't recognize just by looking at the graph. We can't figure out. But it will have some mean value, but we can find it mathematically. Graphically, we can't look at it and recognize the mean value. But here, yes, we can look at it. So the point I want to make is I've given examples. The reason is the shape can be anything. The shape need not be some predefined shape. The shape can be anything only if you can recognize that it is having some symmetry. It is having even symmetry with respect to some point, not with respect to axis. It can be having symmetry with respect to any point. Then definitely we can recognize the mean value graphically itself. Without putting your pen, you can recognize the mean value. But remaining values, mean square value and all the others, you have to find out with with basic procedure like this. Is that okay? I hope it is clear to this point. For uniform PDF, we have found the mean value. Let us also find the mean square value. Let us also find the mean square value. Expectation of x square. Observe carefully. Integration from minus infinity to plus infinity. X square into fx of x dx. Simple basic. This is equal to integration from minus infinity to, sorry, it is x square. Now what is the equation of the PDF? It is 1 by b minus a. That 1 by b minus a equation is valid only in the limits from a to b. Only in the limits from a to b, this equation is valid. So substitute the limits a to b, and in the remaining limits, this function value is 0. So 1 by b minus a outside into x square, we can write as x cube divided by 3, limits from a to b. So we can write it as b cube minus a cube divided by b minus a. So b cube minus a cube divided by b minus a. B cube minus a cube, and I can write it as b minus a into b square plus a square plus ab, something like that. So a square plus ab plus b square divided by 3. See this? So I substituted b cube minus a cube, we got b cube minus a cube divided by b minus a, we got this. That's it, we got the result. We got expectation of x square. We got expectation of x square. Next, let us also find one more parameter which is important for us. Let us also find the variance. Sigma x square or sigma square is equal to mean square value, which is total power, minus mean whole square, which is DC power. Variance, if you are talking about a random variable which represents voltage or current, then definitely variance we can call it as AC power. Variance will represent AC power if x represents voltage or current. Mean square value represents total average power. Mean whole square represents DC power. Expectation of x square we know it is a square plus ab plus b square divided by 3 minus mean whole square. What is mean whole square? It is a plus b by 2 whole square. Okay, so if you resolve it, 12 in the denominator. So here it is a square plus b square plus 2ab divided by 4. Okay, so if you calculate, this will be 4a square, 4ab, 4b square minus 3a square, 3b square. 3a square and 3b square, if you subtract, it will become a square and b square, and this is 4ab, and here it will be 6ab. So it will be finally b minus a whole square divided by 12. You just process this. You can just calculate in your own way. Finally, it will turn out, what remains is, once you take the once you combine these two terms, what you'll get is b square plus a square minus 2ab, b square minus a square, b square plus a square minus 2ab, which we can write as b minus a whole square or a minus b whole square. Since b is bigger, that's why I'm writing it as b minus a whole square by 12. So finally, that is the answer. So whenever you see a uniform random variable, if you know the starting point and ending point of uniform random variable, yes, you can calculate the mean just like that in few seconds, variance in few seconds, and mean square value in few seconds. Very simple stuff. If you forgot these formulas, that is fine. We can calculate the same way we have calculated here. Hardly we have took 1 minute or less than that to calculate mean square and variance values. Okay. So if you forget also, you can calculate it directly using the basics. But it is worth, remember, generally I don't suggest you to remember too many things, but here for uniform random variable especially, it is worth remembering these basics. So mean value is easy to remember because mean value is just the midpoint. There is nothing to remember here. If you want to find the midpoint, you know how to find the midpoint from your school basics itself. Midpoint means just the average of the starting point and ending point. There is nothing to remember here. And for this one, this looks like little tricky to remember, but once you use 2 or 3 times, yes, you'll remember definitely. But even if you don't remember this, that's fine. Remember this. This is more easy, right? This is straightforward. There is nothing to remember here because midpoint only, na? For midpoint there is nothing to remember here. But this one you can easily remember, b minus a whole square by 12, variance. Once you know variance and you can figure out the mean value easily. If you know variance and mean square value, can we not figure out the once you know variance and mean value, can we not figure out the mean square value? If you know mean, square it, you get the DC power. If you know variance, you know AC power. Just add the AC power and DC power, you get the total average power or mean square value. So if you don't remember this also, that is fine, but remember this one. And you know this anyway. Using these two, you can find this. Fine. If you remember this also, that is also fine. But don't try to remember too many things. Remember only least number of things possible. Only that is definitely necessary. Only those things you have to try to remember. Other things you have to get from the logics only, from the basics. Right? So that is the understanding of uniform random variable. Okay. So let me ask you some questions here. A uniform random variable takes values -2 to 12. I'm asking you now, find first question mean value, second question variance, third question mean square value. First three questions. First answer me these three questions quickly. Should not be taking more than half a minute. Anyone? Okay. Look on C, expectation of x square. I have discussed this relation in day before yesterday class. And yesterday's class also I have discussed, if you remember. Expectation of x square is equal to sigma x square plus expectation of x whole square. This is one way of writing it. Other way of writing it is x square bar is mean square value. This is variance plus mean is x bar whole square. This is the relation you should be knowing already, right? This is AC power. This is AC power. This is DC power. This is total power. Okay. Right. Can you tell me the mean value? Simple. It is a plus b by 2, or just the midpoint of starting value and a final value, which is -2 plus 12 divided by 2, which is equal to 5. Next, variance. B minus a whole square divided by 12. So b minus a is how much? 12 minus of -2. It is 14 square. 12 minus of -2 is 14 square divided by 12. So it is 14 into 14 by 12. So 2 from here, you can cancel. So it will be 7 sevens of 49 divided by 3. You can stop it at that place. How about mean square value? Mean square value is equal to variance plus mean whole square. Mean square value equal to variance plus mean whole square. This is mean of squared value. This is mean whole square. There is a difference. This represents DC power. If x is representing voltage or current, we can call it as DC power, and this we can call it as total power or total average power. This is AC power or average AC power. This is average DC power or just DC power, both are same. Okay. So variance we got it as 49 by 3, and mean value is 5. So it will be 5 square will be the DC power. So 25 plus 3, 25 into 3 is 75. So 75 plus 49 is 124 divided by 3. Is that okay? Yes, I think it is correct. Yeah, 41.33. Correct. Gokulan, I hope you are following. Let me know if you are facing difficulty anywhere. If you're done with these three questions, I'll ask you one more question from the same with the same data. Okay. So I'll ask you a few more questions which we are used to it. So we have done this kind of questions many times. I'll ask them quickly. Give me the answers. The regular questions, regular probability kind of questions. So fourth question. So find probability that x takes values between 0 to 6. One more. What is the probability that x takes values greater than 5? So to do this, you have to plot the PDF. We have not plotted the PDF here. So from the given data, y-axis here, from -2 to 12, these are the values taken by the random variable x. So if it is uniform PDF, it looks like a rectangle from -2 to 12. This is how it looks like. What is the height here? Height should be in such a manner that the area will be 1. So width is 14, so height should be 1 by 14. Okay, this is how it looks like. Now P of x between 0 and 6. 0 and 6 it seems. From 0 till 6. From 0 till 6, we want the probabilities. So add up the probabilities of the random variable between 0 and 6. So just add up the probabilities. How do you add up? Since it is continuous function, just integrate or find the area from 0 to 6. This area is what they're talking about. So how much is that area? 0 to 6. The width is 6 units and height is 1 by 14 units. It is 3 by 7. Or the meaning of this is integrate or add up all the probabilities from 0 to 6 in the PDF. Take the PDF which has the information of probabilities and add up the probabilities from 0 to 6. Which means integrate the PDF from 0 to 6. That will give us the answer 3 by 7. Next one, how about P of x greater than 5? X greater than 5 means you are interested in the values from 5 to infinity. Add up the probabilities of the random variable from 5 till infinity. What is the area from 5 to infinity? From 5 to infinity, what is the area? From 5 to 12 only we have non-significant area. After 12 there is no area. So from 5 to 12, what is the area? 5 to 12, if you look at the shape, it looks like a rectangle shape. Just let us find the area. What is the width? 5 to 12, what is the width? 7 units. From 5 to 12, the width is, whenever you want to find the width, highest value minus lowest value will give you the width. 5 to 12, 12 minus 5 will give you the width, which is 7. And height is 1 by 14, which is 1 by 2. Okay. So like this, they can ask you questions. Shall we move to the next one? So we'll talk about the next random variable, which is exponential random variable. Exponential random variable or exponential distribution, you can call it. Okay, so how does it look like? If x is an exponential random variable, then how does it look like? If you plot it, as a function of x, The basic exponential PDF looks like this. It starts from 0 and keeps on decreasing, exponentially decreasing function, something like this. Should it start only at 0? Need not be. It can start anywhere, but this is the very basic version of exponential PDF we can plot. Exponential means it is exponentially decreasing. It can't be exponential. Any PDF can't be exponentially increasing for infinite duration, because if it is exponentially increasing, its area cannot be 1. Only exponentially decreasing functions can have an area of 1. Okay, exponentially decreasing functions need not have an area of 1, but functions, exponential functions which have an area of 1, only they can be called as PDFs, because PDF should have an area of 1. Right. So this is one type of exponential PDF I'm plotting, but you can plot a PDF which starts from -2, -3, 4, 4, 5. It can start from anywhere. Okay, but this is the basic version that we will talk about. So using that, you can apply the basics to exponential PDFs which start at different points also. So let me denote the PDF as fx of x. So the equation for this is a into e power minus bx, something like this. Let us write it as a into e power minus bx, and this is valid only for x greater than 0. Okay, and the equation is 0 elsewhere, or for x less than 0 it is 0. So we can write this total thing as a into e power minus bx into u of x. See here. So can we guarantee that? So we have written the equation of some exponential graph, but can we guarantee that its area will be 1? Only if its area is 1, only then we can call it as exponential PDF, right? If you want to call it as PDF, its area should be 1. So let us make sure that the area is 1. Okay. So integration from minus infinity to plus infinity, fx of x dx should be equal to 1. This implies a into e power minus bx, integration from minus infinity to plus infinity dx should be equal to 1. But this equation is valid only for positive values of x. So let us change the lower limit to 0. Because from minus infinity to 0, the equation of the PDF is 0. And only from 0 to infinity, it has an equation of a into e power minus bx. So this implies a into e power minus bx, after integration it becomes divided by minus b. Limits from 0 to infinity. If you want this to be equal to 1, so this is a divided by minus b. If you substitute the limits, e power minus infinity is 0. E power minus infinity is 0 minus e power 0 is 1. This implies a should be equal to b. Or a by b should be equal to 1. Only then the area will be equal to 1. So this area of this PDF, area of this graph need not be 1. Area of this graph will be 1 only if a and b are equal. Only if a and b are equal. So hence, what is the equation of the PDF? Shall we write the equation of the PDF? You can change the equation to a into e power minus ax, because a and b should be equal for the PDF, for the area to be 1. This value here and the value here, this value here and the value here, they should be exactly equal. Only if they are equal, only then the area will be equal to 1. So in an exponential random variable which looks like this, the constant that is multiplied, or the amplitude at 0, the amplitude at the peak amplitude, and whatever is the constant multiplied in the power, both of them should be equal. Okay, very good. So we understood only the PDF part. Next, we will understand few more things about modified versions of these exponential random variables a little later in the next slide. But for now, first let us talk about some other important stuff. Let's calculate the moments. Find the first order moment. Let's find the first order moment or mean value. Integration of x into fx of x dx. This is a basic relation for first order moment or mean value. Let us calculate it. Integration of x into, what is the equation of PDF? It is a into e power minus ax dx. Limits from 0 to infinity. Only from 0 to infinity the equation of PDF is this much. This is valid only from 0 to infinity. So this is equal to, you can write it as x into a into e power minus ax divided by minus a, okay, minus x differentiation is 1 into a into e power minus ax divided by, already minus a is there, one more minus a, it will become minus a whole square. Okay, so limits from 0 to infinity. So if you substitute infinity here, e power minus infinity is 0. If you substitute infinity here, it becomes 0. Upper limit will give you only 0. Next, how about the lower limit? If you substitute lower limit, if you substitute upper limit, it is 0 minus 0 minus of upper limit is substituted, it becomes both are zeros, both terms will give 0. If you substitute 0, then 0 into anything is 0 minus of minus. So how about if you substitute 0 here? E power 0 becomes 1. E power 0 becomes 1. And yeah, correct. E power 0 becomes 1. And what remains here is a divided by minus a whole square. Minus a whole square is a square. Right? 1a gets cancelled. What remains is minus 1 by a multiplied with minus sign. Final result is only 1 by a. See this? The mean value is very easy to find. Whatever is the maximum height here, whatever is the maximum height of the exponential PDF, inverse of it will be the mean value. See this? Very closely related. Whatever is the value here, that should be the value in the power also. And there should be a minus sign definitely, otherwise it will not be exponentially decreasing. Only because of this minus sign, it is exponentially decreasing. The value here and value here are same, and the value here and the value here, if you invert it, if you do the reverse of it, that will give us the mean value. Okay. Similarly, let us calculate the mean square value and variance also. Let's do it. Expectation of x square, it is equal to integration of x square into fx of x dx. Using this formula, mathematical formula, if you want to find the variance or mean square value, it's better to find mean square value, because mean square value is just x square, whereas variance is x minus x bar whole square. Integrating x square is easy, or x minus x bar whole square is easy. Obviously this is more easy, right? So that's why if you have to use mathematical formulas for mean square value and variance, so try to find out variance. Once you find out variance, using variance and mean value, you can find variance. Sorry, using mean square value and mean, you can find variance. I guess you're following. Mean is easy to find, and if you know mean square value and variance, these are the two things that we have to find. Okay, so which is more easy? Mean square value, variance, we can write the formula as x minus x bar whole square into fx of x dx. So all of them we can find using formulas only, but there is an easy relation, no? Among these two, which is easy to find? This is more easy to find. This looks less complicated, right? And for this one, instead of doing this complicated stuff, we can take the help of mean square value, because we have already found it, and then we can subtract it. We can subtract the mean whole square, which is dc power. Mean square value minus mean whole square will give us the variance. So this is integration of x square into what is the equation of fx of x? It is a into e power minus ax dx. Limits from 0 to infinity. I have substituted this equation. This equation is valid only from 0 to infinity. So let's integrate it. It is x square. I am applying UV rule, integration of UV. A into e power minus ax divided by minus a minus 2x into a into e power minus ax divided by minus a whole square minus 2x differentiation is 2. I think alternate plus minus, right? Should be plus. A into e power minus ax divided by minus a whole cube. Okay, I am applying UV rule, integration of UV rule. Now let us substitute the limits. Integration from 0 to infinity. If you substitute infinity, upper limit, infinity here, infinity here, infinity here, e power minus infinity is 0. So 0 minus 0 minus 0 plus 0 with the upper limit minus of, let us substitute the lower limit also. If you substitute 0, 0 here, 0 here, the first two terms will go off. Next last term is plus 2 times a into e power 0. E power 0 is 1 divided by minus a whole cube. So what is this? This minus a whole cube is minus a cube. This minus sign and this minus sign will go off. And what remains is this a and a, 1a gets cancelled here. What remains is a square here. Minus a square will be there. 2 by minus a square, and with minus this minus sign it becomes 2 by a square. That's it, as simple as that. Now let us find the variance. Variance is mean square value, which is 2 by a square minus, what is the mean value? We have calculated previously. Mean value is 1 by a. So it is 1 by a is the mean value. If you square it, we get the DC power or mean whole square, which is equal to 1 by a square again. So this 2 by a square minus 1 by a square is 1 by a square. So finally, for an exponential distribution, mean value is 1 by a, mean square value is 2 by a square, variance is 1 by a square. See how easy it is to remember also. It's easy to remember, right? So this is the analysis of exponential random variable. So for an exponential random variable, they can ask you questions based on probability also, something like this. Something like this also they can ask. So then it is basic procedure only. Any PDF with any shape, it is the same basics. So if they ask you this kind of question, you just integrate it. Whatever is the equation is substituted here, you'll get the answer. Okay. So for exponential random variable, we have talked about the equation. How should be the equation so that the area will be 1? We have figured out that. Okay. See, if they have given you some other exponential random variable, maybe with the two-sided exponential, okay, or else something little different from what we have discussed, then just go with the basics. Whatever we have discussed here is from the basics only. We have not by-hearted anything. Okay, we have not used any particular standard result here. Okay, we have gone with the very basics. We have gone with the properties of PDF. Area should be 1. If you use that, you will understand whatever. If there are two variables here, you'll know the relation between them if you just apply this basic. Correct? So this is the basic exponential PDF. Now let me discuss variations on it. Little small variations on it. Okay. Instead of the PDF starting at 0, how about if a PDF starts here? Let me say it is starting at some point C as a function of x. Let me say the height is a. This is, let me take a different variable here because already we have used x now. Observe carefully. The variable is y, and let us represent the PDF as fy of y. Can anyone tell me the equation for this? Same stuff, na? Same stuff, similar stuff, not exactly same, similar stuff. Does it not look like the same height a here, same height a here? Whatever is the height here, that is the constant multiplied. The same thing is there in the power also. This and this graph, they look exactly the same thing, no? Not exactly, similar. They're like similar. Only thing is they are looking like shifted versions. Right? So how do we write the equation for it? So if it was here, then I would write it as a into e power minus ay, something like that. If it was starting from 0, okay, into u of x, something like that. But here, since it is starting from c, I'll write it as a into y minus c, as simple as that. If it was a PDF like this, see, just apply your signals and system basics, very simple basics, math basics, you can say. As a function of y, if it starts from here, I would write it as a into e power minus ay. Correct? Now, this from this and this, what is the relation between these two functions? If you look at it as g of x, this is looking like g of x minus c. This is into u of x also. A into e power minus ay into u of x, that is the equation for this. Now this is looking like g of x. And how is this looking like? If this function is looking like g of x, this function is looking like g of x, then this looks like g of x minus c, as simple as that. Write whatever you know first and find the relation with whatever they have given us. Find the relation between whatever you know and what they have given. So what you know is g of x, let's say, and what they have given is nothing but g of x minus c. So you know the equation for g of x because we have discussed about this kind of shape. So if this is looking like g of x minus c, replace everywhere. Sorry, if I have taken the variable as x, then it is g of x. If taken the variable as y, then it is g of y. Okay. So g of x minus c means it is a into e power minus a into x minus c into u of x minus c, something like that, into u of x minus c. But here, since the variable is y, instead of writing x minus c into u of x into u of minus c, so g of x minus c means replace everywhere x with x minus c. I don't know if I have written it clearly or not. Let me write it again. A into e power minus ax. That is how we have written it in the previous slide also. Into u of x, because it exists only for positive values of x. I am calling this function as g of x. Okay. Now this function and this function, what is the relation? This function looks like shifted version of it. This function shifted towards the right side by c units, we get this function. From 0, it is shifted to c units. So this looks like g of x minus c. So what is g of x minus c? It is a into e power minus a into x minus c into u of x minus c. Is that okay? But here the variable is y, it's not x. So let's change the variable to y. If this is g of y, then this is looking like g of y minus c. So g of y minus c is a into e power minus a into y minus c into u of y minus c. Simple stuff, see? Into u of y minus c. It's not so difficult. Just compare it with whatever you know already, you can easily get the equation. So many things are same here. See, the maximum value here, that is same. Okay. And the constant that is multiplied in the power, that is also same stuff. This value is height and the constant multiplied here. These two are same here also. Only thing is this is just shifted towards right side. That's why, because of shifting, instead of having e power minus ay or minus ax, we are having variable minus that shifting factor. And here also that shifting factor, because this exists starting from c. That's why we are writing it as u of y minus c. Simple stuff, right? So could you tell me what is the mean value here? Anybody? Can anyone tell me what is the mean value? Anyone can tell me the mean value? See, here the random variable is y, okay? Random variable is y. Now what is the relation with that, with the x here? Is it not looking like x minus c or x plus c? No, x plus c. The relation between y and x is y equal to x plus c, correct? So when x is 0, whatever is the value taken by x at 0, the same value is taken at c, correct? The same height is there at 0 for x value variable and at c for y variable. So this is the relation between y and x. If you can observe the relation between this random variable and the PDF of the random variable that we already know, then things will become easy. I hope you understood this part. Common sense stuff. This is just shifting, right? Since this is just shifting, or else you can observe from here. In place of x, we have replaced y minus c. So y minus c equal to x, you can write, which means y equal to x plus c. Correct? We can write it like this. Or y minus c equal to x, which means y equal to x plus c. Right. So now let's find y bar. Y bar is equal to x bar plus c. What is x bar? We know what is x bar. What is x bar here? X bar is simple. It is 1 by a. 1 by a plus c. So observe, when the exponential PDF is shifted towards right side or left side, if the starting point is not 0, whatever values we have derived for exponential PDF is assuming that it starts from 0. It starts from 0, something like this. With this assumption only, we remember the mean value, variance, and mean square value. If the starting position changes, then mean square value, and variance might change. So we have to be careful. So if you establish the relation between the two random variables that we are talking about, shifted PDF and original PDF that we remember, then using that we can find the values very easy. Sir, this is looking a little tricky, this procedure. Okay, fine. Just go with the basics. Okay, if you want to find the mean value, if you don't establish this relation, if you know the equation, just go ahead. If you want expectation of y, integration of y into fy of by dy. In the mean value formula, just substitute this and get the mean value. Substitute this in the mean square formula and get the mean square value. Or you can do it this way also. Any procedure which you are comfortable, you can go ahead. Right, next, how about mean square value? Okay, or else variance is more easy to find. Whenever you are adding with a constant will not change the variance. Why? Because adding with a constant only changes the DC value or DC power. Constant only changes the DC power. Constant will not change the AC power. Why? Okay, and if you can go mathematically also, we can understand it mathematically as well. Sigma y square is expectation of y minus y bar whole square. And what do we know about y? Y is given as x plus c. Minus of y bar is what? Y bar is x bar plus c. C whole square. C and c gets cancelled. Now what is it looking like? It is expectation of x minus x bar whole square, which is same as the variance of x. I told this previously also. If it is left-sided, means it is a different discussion altogether, Gokula. You can try to figure out, and you can ask me there for help in the Telegram group. Okay, left-sided means I think you are talking about this kind of stuff, right? If it is this kind of PDF, then the answers will be completely different, because we have talked about exponential PDF, which starts from a point and it decreases when you go towards positive values of x, right? For this also we can figure out in a similar manner, but I don't want you to remember too many things. When the graph they have given is different from what we have discussed, okay, then it's better to go with the basics. The same way we have discussed, see, whatever we have discussed in today's session is from the basics only, right? The same way you can derive if the graph is different from what we have discussed. So this is the graph that we have discussed. This is the graph that we have in mind. But if this graph is shifted towards right side or left side, that is fine. Okay. So this graph also you can deal with, because this graph looks like reversed version of this, means y-axis inverted version of this. Yes, you can deal with this graph also. Like this, if you keep on analyzing, we'll have many graphs. Okay, but you can take it as a homework and try to figure it out. So for this graph, try to figure out the PDF, try to figure out the mean square, variance values. Okay, once you figure out, if you want confirmation about the answers, you can post it in the group. I can help you out. If it starts from -2 to infinity, yeah? Okay, if it starts from -2 to infinity, then also it is same, then c will be negative, na? Same basic only. Did I tell you that it is shifted towards right side? C, if c is positive, then it is shifted, it is like shifting towards right side. If c is negative, I've taken only c, I did not take it as 2 or -2, I did not take any value, that which means c, based on c value, it can be shifting towards right side or shifting towards left side also. Correct? Okay, so variance of y and variance of x are same in this case. The reason is the relation between x and y is only a constant. A constant is added, you got the new random variable. When a constant is added to a random variable, the variance will not change. Whenever a constant is added, variance will not change, because when constant is added, your mean value changes or DC value changes. When DC value changes, only DC power will change, AC power will not change. So that's why variance will not change when a constant is added. Right. So how about variance of x? We already know that, right? It is 1 by a square is the variance of this random variable. Right. Next, expectation of y square. How about that? Expectation of y square is equal to sigma y square plus y bar square. Sigma y square we already know, 1 by a square, which does not change, variance does not change, but mean value changes. 1 by a plus c also. Okay, fine, I hope it is clear. So this is the understanding of exponential random variable. See, they can talk about, they can give you different, completely different shape. Just go with the basics, you can analyze it easily, have the confidence, have that confidence. Right. I'll give you one more type of exponential random variable also, which is two-sided, something like this. So what we have discussed in the previous slides is an exponential graph which exists only on one side. But here I've given you a graph where it exists on two sides as a function of x. This is fx of x. Let me say the height is a. Let me write it as a into e power minus b mod x. I'm writing this equation, mod e power minus mod x kind of equation it will have. So some constant here, some constant here. We don't know if those constants are same or not. Right? We don't know if these constants are same or not. So let us figure out integration from minus infinity to any shape. Just go with this basics. If you find the area of it, that should be equal to 1, right? So is the area from minus infinity to 0, this area and this area, are they same or not? They're same, right? Can I write it as 2 times integration from 0 to infinity? Because this is a symmetric graph. This is a symmetric graph. You can write it this way, correct? Instead of finding the total area, I'm writing as 2 times of this area or 2 times of this area. Whenever you see a symmetric graph, even symmetric graph, you don't need to find the total area, you just need to find half of the area, because this half and this half are equal. There is 2 times integration from 0 to infinity. What is the equation of the PDF? For positive values of x, mod x can be written as just x. So we can write as e power minus b. Instead of mod x, I'll write it as x because we're talking about positive values of x. So 2a outside, e power minus bx divided by minus b, limits from 0 to infinity. So it is 2a divided by b minus b. So if you substitute infinity, it becomes e power in minus infinity, which is 0, minus, if you substitute 0 here, e power 0 is 1. My mistake here. I've done a mistake here, I think. Yeah. Very good. So this should be equal to 1. Say minus 1 into minus will become plus. So 2a should be equal to b. 2a should be equal to b, or a should be equal to b by 2. Now you can change this equation. You can change this equation as a into e to the power of, instead of b, you can substitute 2a. You can substitute 2a, or you can also write it as b. Instead of a, we can write as b by 2 into e power minus b mod x. So the relation between these two values is the value in the power should be double of what is the value here. Whatever is the value here, the value here should be double of it. Is that okay? So don't by heart things. So when you remember things, you have to understand for what you are remembering. For this PDF, the value here and the value here are same. But if it is a two-sided exponential, same thing is not valid. Correct? So only remember for this. Only remember for this, because this is a standard distribution which you will find many times. But if they want to make it tricky, they might give you this kind of PDF. Or this PDF is not very tricky, but it is a two-sided exponential where the relation between the power and the peak amplitude is not same. Okay. So they can play around with this kind of modified distributions also, modified exponential distributions also. Then we have to be careful. We have to be confident of our basics, and we have to solve. Okay. Is it clear to this point? So any confusion, just take the graph, whatever, wherever there is confusion, and just try to analyze it on your own, using your own basics, using your own understanding. Just try to analyze it on your own. If you face any difficulty, mostly it will be clear for you once you analyze it on your own. But if you face any difficulty, you can, I'm always there in the Telegram group. I can help you out. Okay. So very good. Okay. I'll ask you one question based on exponential random variable, and then we will move on. An exponential random variable has a PDF fx of x is equal to 4 into e power minus 4x into u of x. Okay. Find, I'll ask you multiple questions here. Find mean value, mean square value, and variance. First find these three. Anyone? Very simple stuff. If you want to plot it also, you can plot it. It looks like this. The maximum height is 4 units. How much is the mean? It is inverse of the maximum height of the exponential PDF. What is the maximum height? 4. The mean value should be 1 by 4. 1 by a only, na? 1 by a into e power minus ax. You can remember that. So 1 by 4 is 0.25. No? Okay, very good. So how about mean square value? Mean square value is given by 2 by a square. In place of a, we are having 4 here. So it is 2 by 16. This is 1 by 8. Or we can also write as 0.125. Next, variance is 1 by a square. This is 1 by 4 square or 1 by 16. Or you can also write as 0.0625. Is it okay? Simple stuff. Moments you can find it easily for exponential PDF. Let me ask you some more questions. So what is the probability that x is greater than 1 by 4? How about that? Any PDF, it is the same basic. So what are they interested in? They are interested in the probability of the values of random variable from 1 by 4 to infinity. Okay, let us substitute. From 1 by 4 to infinity, what is the equation of the PDF? We know the equation, it is 4 into e power minus 4x dx. Integrated, it is 4 into e power minus 4x divided by minus 4. Limits from 1 by 4 to infinity. So 4 and 4 gets cancelled. So if you substitute infinity here, it is e power minus infinity is 0 minus, substitute 1 by 4, it becomes e power minus 4 into 1 by 4 is minus 1 divided by minus 1 is already there. It will be e power minus or 1 by e it is. Very good. Next, how about one more question I'll ask you. How about this? I'm asking you to find the probability of the random variable taking values from 1 to 2. Integration from 1 to 2 fx of x dx. Very simple basics. Add up the probabilities from 1 to 2. Since it is continuous graph, we are just doing integration to add up the probabilities. Integration from 1 to 2, 4 into e power minus 4x dx, which is equal to 4 into e power minus 4x divided by minus 4, limits from 1 to 2. 4 and 4 gets cancelled. If you substitute the limits, it will be e power minus 4 minus e power minus 8. Okay. So with that, we have discussed problems based on exponential random variable as well. So one more point I want to discuss here, and that is one more point that I want to cover is the CDF. For uniform random variable, what is the CDF? Let us find it quickly. Very simple stuff. A to B as a function of x if this is PDF of a random variable, the height is 1 by b minus a. Now if you can integrate it, you'll get the CDF, right? CDF fx of x, if you plot it, this accumulated PDF from minus infinity till a, there is nothing to accumulate, but from a to b, there is something to accumulate. So integrate this function to get the CDF. 1 by b minus a, constant integrated, it becomes 1 by b minus a into x kind of function. It's linear function. Now after b, there is nothing to accumulate, so it will stay constant. So CDF will be something like this. The height here will be 1. The height here will be 1. And the slope of this is 1 by b minus a, because when you integrate, the amplitude of the graph, amplitude of PDF will become slope of the CDF. That is what happens whenever you integrate a function. Similarly, let us talk about the next PDF, which is exponential PDF. Now if you integrate this, so if you integrate this function, there is nothing to accumulate till 0, and after that there is something to accumulate. So there is something to accumulate, and then after, as x increases, there is very little to accumulate. It increases, but it increases very little as we go on. Finally it becomes 1. CDF, after some point it becomes 1, or at infinity it becomes 1. So this is how the CDF looks like. If you integrate using your basics, it is going to look like 1 minus e power minus ax, something like that. At x equal to infinity, it becomes 1 minus 0, which is 1. So this is how it looks like. CDF function looks like this. So it is looking like some kind of increasing exponential, something like that. 1 minus of decreasing exponential, it's something like increasing kind of exponential. So these are the CDFs. This is the CDF for any uniform PDF. Has a CDF which is looking like increasing shape for some time, and after for some duration, and after that it will stay constant. For exponential graph, this is how the CDF looks like. It starts from 0 only, because see, yeah, that's a good question, Gokul. See here, how much is the accumulated PDF here? The probability at 0 is good. So overall, for all the, compared to all the values of x equal to 0 or close to 0 values have highest probability. But that probability, how much is that probability? Let me ask you a question here. What is the probability that x equal to 0? Can you tell me? It is approximately 0, no? Correct or not? So what is the probability at 0? The probability density is maximum. How much is the probability? If you want probability, you have to find the area, this area. Okay, almost 0. It's not exactly 0, it's almost 0. So what is the probability accumulated from here, this point to this point? Almost 0. So that's why it is increasing. It's not 1, it's only 0. It starts from 0. But because the height is more here, the slope will be more here. So amplitude becomes slope in the integrated graph. This amplitude becomes the slope here. Or the slope of this graph is the amplitude of this graph. Fine. So that's it from my side in today's session. So I've talked about uniform random variable and exponential random variables. In tomorrow's session, we'll solve wonderful questions based on all the concepts that I've discussed in the last 5 sessions. So today is the 5th session. From 1st to 5th session, in all these 5 sessions, we've talked about PDF, CDF, moments, Gaussian random variable, uniform random variable, and exponential random variable. So based on all these concepts, I'll ask you some wonderful questions. We'll solve some wonderful questions in tomorrow's session. Fine. Very good. So if you have not subscribed, subscribe to the channel and like the video if you like the content that I've provided. So fine then. So that's it for today. So take care. Meet you next time in tomorrow's session. Bye for now.